my machine. So we'll pick up, we're going chapter 9, POODR. Andrew started it, and we will continue, and looking at the content is probably worth a little bit of a review. So I'll turn it over to Andrew, and welcome.
All right, thank you. Here, show. So last time we had just finished talking about testing incoming messages. Incoming messages are methods that an object responds to. For example, in this case, it was wheel. Before, it would respond to diameter, but then later Sandy changes it so that it responds to width and no longer to diameter. And to kind of jump back in, we were looking at the fragility of doubles, where if we have a double up here, let's see. Well, here's the table. Let me just start from here then. Here's a table outlining different incoming messages and outgoing messages. Wheel has one message, and it's an incoming message, which is diameter. It's dependent. Gear depends on wheel having diameter. We can see that diameter is also gear's outgoing message. We'll talk later about the differences in outgoing messages and how to test those. All right, and then gear also has two incoming messages, gear inches and ratio. So we'll go through. We left off where Sandy was introducing doubles into her test, but we'll just start here in isolating the object under test. So here we see that wheel is no longer, the class wheel is no longer coupled to gear. It's now an injectable, and now it's injected so that any object that can respond to diameter works well in the gear object. She calls that kind of object that responds to diameter diameterizable. And so that allows us to, in case wheel is a resource heavy or complex code that takes up too much time, it could now be replaced by something else. Here we see that the test is rewritten with wheel being injected. So it still works like before. It's just now that we're able to replace wheel with something else that can respond to diameter. Here she changes wheel's incoming message. It no longer responds to diameter, and now only responds to width, which is the same functionality as diameter, but gear inches no longer works because it expects the wheel object that was injected to respond to diameter. So the test as is here works. It lets us know that the underlying code is no longer working, and so that's a true positive, negative. I don't know how to say it, but it's working in the sense that test lets us know that something's wrong, that we have to dive in and figure out what's going on. So now we go into the realm of testing roles, and later on we'll develop interfaces. But for now, Sandy just wants us dealing with doubles. So here's a simple diagram of what's going on. We have a wheel object that behaves like a diameterizable by just having a diameter incoming message of diameter, and that gear expects that wheel to have diameter. So she goes on to say how it's great to be able to inject different objects instead of having something that's coupled directly. So now we finally create our test doubles. The test double, fairly simple. It's just an object named diameter double, and it has one method diameter, which is step. But the nice thing is that wheel could have many other methods that are complicated. With a double, it's a very simple calculation. So imagine like, to calculate diameter involves like an entire math library. And so now diameter is just a constant 10 or integer 10. And so it's very little work to create a diameter double, so that the test is that much quicker. But the issue is that here's the whole like mocks aren't necessarily doubles. She goes into more explanation of what mocks are, but yeah, in this test, she runs it and she says, yeah, everything passes great, everything's beautiful. But later on, we have an issue because if we remember that she changes wheel to no longer respond to diameter, but to respond to width, we see that the test still passes because the gear inches method still calls a diameter method on the object that was injected. And that's still diameter double, so the test passes. But when the code actually runs, we should expect an error because gear inches never takes into account that wheel has a new method and it no longer responds to diameter. So this is a false positive. This gear test passed, and that's pretty dangerous. And she calls it the brittleness of working with doubles, that your test looks like everything's passing, but in reality, there could be serious issues going on, and those won't become apparent until later when the code is actually expected to work. So yeah, so she says, it's no wonder this problem occurs because the roll is nearly invisible. So what do we mean by that? She begins to write a new type of test method called the object responds to a method. So so now instead of just doing one test, which was calculates diameter, she's now saying that the object wheel has to respond to diameter. And so, and in context, it seems like this should fail, but I don't know at what stage wheel is here, whether it still only has diameter or it has width. So if it has width, this should fail, this should pass. But we'll go back to this later on. She then goes on to what to do with testing private methods. This is a short section.
Hey, Andrew.
Oh, yeah.
Let's pause a little bit here.
Okay.
So this is a good example of how overusing test doubles, or not necessarily overusing, it is one of the problems when you use a double that's not the real object, sometimes it changes. So this is the perfect example of, oh, well, wheel gets changed, which is in fact the actual double that gets tested. Right. So wheel change, but since we did a double here, test keeps passing because what happened here is because our double diverged from the interface of the actual one that we use. And it's something here that sometimes is easier in statically typed languages, right? If we expect something to implement an interface, then if that interface changes and our double doesn't match the interface, the compiler checks that. that's something that's actually a drawback in dynamic languages. And that being said, down the road, as far as Java, they evolved the types where they'll have mocks and other kinds of doubles that kind of understand what the interface or the parent class should be. So it can warn you that. And I think someone did that for Ruby, where you can make a mock that looks at the class and ensures that you match. I have to go check. I think someone tried to do that for Ruby, which shouldn't be that hard as long as you pass the class in. So anyways, this is something that if you've written a lot of mocks, you can get caught by this. It's happened on our project. It's happened on things on the side. It's also kind of why I prefer to use the real object as much as possible. And the beauty is in our spec is you can take an object and then just modify that object. Actually, you can do that in general with Ruby. Our spec just makes it really easy to take any object and then add expectation or a stub functionality. So I tend to like use real objects and maybe stub something in that to change it. Which, of course, if you stub the method you're testing for, will still get broken for the same reasons. But if you test something complicated, for example, you do something that does calculation, I can put in a real object and change either some value either through the attribute or maybe from some query call it makes, and then it calls the interface method, which I didn't stub, but I rig it so that the math turns out to be what I wanted to do. So in general, I lean towards this. But then she has the stuff in isolating where, in truth, unit testing, you're supposed to isolate just your class. So in theory, you can make an integration test, which is more than one class. At the simplest definition, you could do that. So it's like, I would just use wheel. Because wheel is so easy to set, I would kind of just use that and not deal with this issue altogether. And then if the wheel thing changes to inches, I'll know and it'll fail like it did in the original. So it's something to weigh. People who do the mockist approach lean towards the mocking, and that can be, if you're not careful, very prone to this kind of stuff. So, all right, go ahead.
I think she also talks about ducks, which is a little bit different from mocks and doubles, but we'll go into that a little bit later. Testing private methods. Like I said, this section is fairly short. Most of it just boils down to don't test private methods for the 3 reasons. If you test a private method, you're kind of doing double work because other tests of the public interface should cover the validity that those private methods are working. The second point is that she claims that private methods are unstable. So in the place where one would expect a class to change, that usually happens to be the private methods. I guess for the fact that we don't test them, and so there's nothing keeping them, but conversely, it's because we test the public interface methods that we expect those to be that those don't change, that those behaviors still remain the same. So if we do need to change something, probably be in the private methods.
Yeah.
And I guess,
yeah, I would just add, if you need to test a private method, maybe it's not really private.
Right. That's something she says. You know, if a private method has to be tested, or there's too many private methods, it might be that those methods have to come out into some other object, or maybe a module, depending on the application. And then finally, she says you can choose to test the private method. It helps later on to refactor and to a point that it is acceptable, but I guess it's just it's not easy for me to just really say why it's acceptable for this point. I can just kind of skip over this, but it just says that it could eventually become a public method, or it could eventually become some other method within a different object. So the idea there is that there's some potential in that method, and it merits just testing it for a bit. to figure out what's going to happen. So now we're on to the main section that we're going to, is testing outgoing messages. So previously, we had discussed that there's two types of outgoing messages. A query, where an outgoing message would say, hey, I would like to know what this method returns, which is a query. And then a command would be, hey, I would want this object to do this behavior. And there's no need for a return value. So I think here she says that we ignore query messages. So I guess that's fine, because why we ignore query messages is that the object that we're sending the query message should have a test for that method, because it's incoming message. So to avoid redundancy, we wouldn't want to test that method twice. So we go on to the next subsection, proving command messages. So here we are no longer talking about gear, inches, and diameter. We're going to talk about a previous chapter where, is this a previous chapter? Oh no, this is still, so now we have a new situation where gear is now depended on by a video game that has different players ride bicycles. And so the idea is that gear has to respond to, let's say, when player one shifts from one gear to another. So that should change, the dynamics of the game. So now there's a few methods, set cog and set chainring, which I imagine set cog, you go from like cog 1 to cog 2. Set chainring would be whatever new chainring. I'm not that familiar with all the inner workings of the bicycle, but I imagine that explains the two shifters on the bicycle. And then a method change to that responds or that returns the value of the new chainring and cog values. Also, to note that we now have this instance variable called observer that we now will go into play for testing. In the proving command, gear now has an observer variable that it has to respond to. And so I'll just jump into the test, because right now I don't remember exactly what happened. But if we go through the test, we see that observer is now a mock. So in this case, okay, I kind of get it. Observer is, let's say, some module or some object in the game that is sending out this change gear. And so what we want to verify in this proving commands is that observer does get the correct message, the correct outgoing message. So in the setup, we have a mock, meaning that observer is now going to be tested to see if the behavior, if the message was sent correctly. So gear now is set with observer, this mock, and has two test methods. We set up observer to have an expectation that the gear's changed. It should change from 52 to 27 when we do set cog on gear. And from what I see is that observer then verifies to say, yes, after this method, I now have 27 instead of 52. Same thing with chainring. It knows that it has I'm saying this wrong. Maybe there's a typo here. I'm not sure. maybe instead of this being set cog, it should be set chainring, or instead of this being 52, it should be 11. Not sure. But regardless, whatever chainring is, let's say it's 11, it expects that after this method set chainring to 42, that it receives 42. And when we run the test, those should pass. So that's the brief introduction to how a mock works. It kind of goes to give a mock an expectation.
So you should go back, when you're talking about parameters, if you go back to the code that shows what the definition of changed is, you can see observer changed passes chainring as the first parameter and cog as the second.
Oh, okay. Oh, thank you. Thank you. Yeah, you're right.
You go up to this. So that's the signature. And that's why you were thinking new value, old value.
Yeah, no, that's right. So here's chainring and here's cog.
Right.
That makes sense. So when we call verify, we expect observer to have. Now I'm getting confused.
So it would assume, it would seem that the mini test mock parameter is changed as the method that is expected to be called. It will return, I think, true, and it will be passed in that array as parameters.
Mm.
That would be, so that's the only thing I can figure the true is. So sometimes you need the value back, but it's clear to me the method is changed, and it's clear to me the parameter is chainring cog.
Mm-hmm.
So the true, I'm guessing, is what it returns. It's something that's actually clearer in the RSpec way of thinking, expects this with that, and returns. It's much more explicit than memorizing the sequence of parameters, which is, in general, a strength of the RSpec interface.
I mean, I would imagine this would be a lot easier if it was like there was a hash that was passed, and then you can see what values are being called. Like, change is a method, true is a return value.
Yeah, you don't need to do that. I think it's a. Yeah, I mean, you could do it that way, but that's prone to non-checked things. Okay, go ahead.
All right. I'll just go on to testing duck types. So here's where I got confused earlier. But here's where we bring back the example that we started in chapter 5, where we have 3 new roles or objects that respond to preparing trip. We have a mechanic who prepares the bicycle, a trip coordinator who buys food, and a driver to gas up and also fill water tank. So before we saw that we used a case where preparer, the case goes through and says, okay, if the preparer is a mechanic, do this. If the preparer is a trip coordinator, do that. And then if if the preparer is a driver, do these 2 methods. Sandy says that this is a bad way of doing things. I kind of agree. It seems like it's a little bit unnecessary. So what she does next is that she no longer has to let trip know what or who the preparers are and what they do explicitly. She makes it so that each of these preparers include their own prepare trip method. And so you can see that now those different methods, prepare bicycle, buy food, gas up, and fill water tank, are all now just known to those preparers.
This is a classical OO technique. Basically, replace. In fact, it's probably the name refactoring something like replace case statement with polymorphism.
Mm-hmm.
The refactoring name is something almost exactly that one, but it's a case. There's a general case of OO refactoring, which is replace conditional. Maybe that's it. Replace conditional with polymorphism.
Mm-hmm.
So that's the classic idea. They all do a prepare, so make it prepare, and then you can add as many preparers as you want. You never change the interface. It's
right.
Becomes clearer. It not only maps the roles more clearly, but it makes the code easier and easier to change.
Yeah, and we'll find out that it makes it easier to test as well. As we see that now the interface only calls prepares. It's injected, prepares, and then it uses the bicycle, customer, and vehicle variables in prepare trip. So now when preparers are called, the self here will then let prepare trip know who is calling it. Right. So we'll go on to testing. And here, which is, I think this is the coolest thing that I've learned in this chapter, is where Sandy creates modules now. So now we have a set of preparers that all kind of pretty much do the same thing, which is prepare trip. And so now she has a very simple module called prepare interface test, which implements a prepare interface. And all it does is asserts that the object responds to prepare trip. So when creating the mechanic test, all she has to do to test whether it would work in the overall trip.prepare is to include prepare interface test, and that's it. Then she can have all the other tests that only mechanics responds to. And the setup is where most of the magic happens, which is weird to say, but she creates a new instance of mechanic and sets that mechanic equal to object, which is also set equal to mechanic. So now all the tests that depend on mechanic work, as well as the prepare interface test, doesn't need to have mechanic up here. As long as object is defined, it'll work fine. That's pretty cool. Again, the same thing with for the trip coordinator. Goes through and has an instance of trip coordinator that's also equal to object and trip coordinator. And then as well, driver, same thing. So in these two objects, they have their own tests testing different qualities of driver and trip coordinator, but as well ensure that it interacts correctly with trip.prepare. So we see that when we run the tests, everything passes. So that's really cool. And goes into a little bit more using modules a little bit. Trip. Module serves as a test and documentation. So here we have the overall trip, and for trip we have one method that says request trip preparation. So this is just testing the outgoing message of prepare, and so we have prepare is now mocked. Trip is a new instance of trip, and we set up prepare so that when it gets past prepare trip, that it responds correctly. I guess this is still like mocks. It's a little bit like I still don't feel like I quite understand how mocks work.
So a mock is, and I'm using like the agile testing terminology comes mostly from thought workers or related, and in particular Gerard Metzerotz, if I'm saying that right. He wrote a big thingy of which I know Martin Fowler went to using his terminology. But long story short, all fake objects that you use, and that's a loaded word, are test doubles. That's everything that can double. The terminology I'm using is like early 2000s. I know they made it more advanced, but there's kind of like three kinds. There's a stub. A stub is there to give you a value, kind of like wheel and diameter. Yeah. I'm not looking for behavior. I just need a number. I need a number 10 so I can calculate your inches. So that's a stub. And her, the way she wrote that one, that's a stub. A mock can be a stub, but a mock is something that is to verify your interaction with it. So that's why they verify. That's why it expects. I expect to be called this method with these values. And then in mini tests and other things, you have that mock, and then that mock has to verify itself. Did you get called the right way? We're plugging in an RSpec where mock verification happens automatically, and there's probably other ones that can do the same thing. It's not just RSpec, but it's nice to put those expectations, and at the end of the test, all mocks get verified. So you expect. So the mock test, you're checking how you interact with the mock, right? Whereas stub is you want a value. And there's also something called fake. A fake acts like the real thing, but is simpler. So you might have something that isn't a real database, but it supports all the calls. That would be a fake. And you use fakes usually because the overhead is high. Like a real database is too slow, so I use an in-memory thingy that has the calls that I want, but it's more complicated. Where it acts like something that's more expensive is usually when you use that one. So yes. Stubs, mocks, and fakes are the primary test double. There's also SPY. SPY doesn't, it's kind of like I said, it kind of doesn't change anything. It just pays attention to things. So, and there's probably some other stuff. I should go and read the latest stuff that Gerard has written, but I'm probably at this point 15 years behind on whatever I've read on that stuff. So going back to your test, if you show your code thing. So I guess you can't show it when I'm talking. So
I mean, I could try to make it permanent. Let's see.
You present to everyone. Is that an option?
I think so.
Let me jump to the page with that one so I can.
Okay.
Shit. Well, anyways, what that's testing, the test is testing that you're calling the preparer the correct way. That's why it's a mock. You want to make sure when you have a preparer, it gets called, i.e. your interaction with the mock is as expected. So the test of that method is it interacts with the preparer in the right way. So I'll let you take it from there, but that's why this test uses a mock. I'm testing the interaction with another object inside of the class.
I'm going to have to just look at this for a little bit just to understand the syntax or just the way the methods are being called. But I'll go on to the next subsection, which is using roles test to validate doubles. So everyone should be quite aware with the brittleness here of the diameter changing. Oh, sorry, the diameter double still having diameter, but gear inches calls width instead. And so we have a false positive, wheel having width instead, and gear inches still calling diameter. So we have a false positive. So the cool thing, what happens in a little bit, is that we have this something called a wheel test, where it says that it checks to see if wheel responds to width. I don't know if I'm getting to it, but it then she creates a module called diameterizable interface test, which is really cool in a sense because now when I was first reading through this chapter, I was very frustrated that she didn't address the fact that there should be something failing if gear inches doesn't call the right, doesn't update its interface. Even if we're using doubles, and even if I just felt like it felt strange not resolving that, and so there was like a section or two that I had to read through before I got to this point. And this point's really cool because now instead of always using the actual wheel object, we can still use the diameter double test. Even though she uses wheel here anyways, but now it checks to say, hey, your object has to respond to width, and so if it is, it passes, and it looks like this passes too. I guess I was imagining something else, but
I don't like that the name of her test. The test is diameterizable, but then it changes the method to width, right? So it's like one of those, well, you changed it from diameter to width, you should probably change the names.
Yeah.
But again, if you just use the real object, you wouldn't have to do any of this stuff.
That's true. Yeah, that's a good point. There, oh man, I wasn't thinking of that before. You know, like how she changes the name of the method, and now she
Yeah,
has
so
like
it's the
a few levels.
diameterizable interface. There is no such diameter method anymore.
Yeah.
That's what it is. It's you change your own usage of it. I kind of just use the method. Again, people might claim that you're overcoupling, at which point, well, then maybe you could move it to an integration test. But the fact is you're using wheel, and if wheel changes, you want to know. And there's trade-offs to everything, but
Yeah.
I kind of don't like the naming or the rigmarole here for no discernible benefit at this moment. It may change when we start using it more widely. But then again, I lean towards not doing it till I have to.
Yeah, that's true. It's the agile way. I might have gotten confused a little bit, but let's just go through this new snippet of code. We still have diameter double. We have this diameterizable interface test, which says that the object has to respond to width. We have our setup where we say the object is diameter double, and we also see the diameter doubles injected into wheel. So now finally we get to see that even if we have diameter double being injected into wheel, we get a test that fails, which says, hey, wheel changed its interface so that it no longer responds to diameter. It only responds to width. And hey, diameter double, we see that you are now the object that kind of doubles wheel. I mean, I don't feel like that's explicitly said, but with this test failing, it kind of leads me to the conclusion that it does. And we still see that gear test has its own test that still passes. So if we fix this test, the first one, this diameterizable, by changing diameter double to width, we see that it passes the diameterizable test. But now it fails gear inches. I mean, the gear test. We go in, we change the code. We finally replace wheel.diameter with wheel.width. And we finally get everything working very nicely. Definitely like puts a bow on that entire issue, that like unresolved conflict.
The more I look at this test, the more I think I don't like it. Because the reality is our code changes because wheel's interface changed.
Yes.
This test is assuming I know in advance it's changed, so I put in this preemptive test. But in truth, you wouldn't have known. It failed the first place because wheel changed underneath it. So when you actually used it, your test showed you the thing changed. For you to have written this test, I would have to telepathically know ahead of time wheel is going to change and put in this test for diameterizable, which is the wrong name now because I'm not calling diameter. You know, it's like solves the problem after the fact, but you would never have come across this.
No. So like I disagree. But so like a few times I've used test doubles and instead of the real object, and I put there a test to make sure that they have the interface. So that if somebody changes in the future, something will fail.
Yeah, but I'm saying the origin of this test is the only reason we moved from wheel.diameter to wheel.width is because wheel changed underneath me. You would not know ahead of time if you didn't use the object that the parameter changed to you. So the little history on why we wrote this is wrong. The only reason we changed from diameter to width is because wheel changed. We don't declare, hey, well, possibly if we're the architect and we decide across the board everything is good. But I'm just saying, if she evolved this test, well, it changed. Look, it fails. Oh, well, good thing. But if I did it with double, I'd lose that. It's like the history on how the test could possibly come to be is slightly off, in my opinion. You have to know ahead of time the interface is going to change, which sometimes is the case, but that's never clearly spelled there.
Yeah, I'm trying to figure out how I would do it, but my experience with tests is so limited that I only have a couple that I think of.
But again, if you just used wheel, you wouldn't have done that. And the first test that fails would have covered the thing that the interface changed.
But here we see that, concluding that section is that we were able to use a module to test something that wasn't easily tested before, and could be shared among different tests and different objects. And I really like that use, and I plan to use it a little bit more often. Here we have our final section, which is testing inherited code. Chapter 6 showed us that we can have different types of bicycles. We can have a road bike, a mountain bike. I don't remember the other ones, so I'll just make some up, like a tandem bicycle, maybe a tricycle. And they all have different arguments. Everyone has size, chain, and tire size, but there could be also more variables, which would be set and post-initialized in those different bike types. We also see all of them respond to spares. Default tire size here, important. Bicycle, an instance of bicycle will raise a not implemented error if it gets called. So that gets brought up later. Then local spares, default chain. So here we see road bike inheriting from bicycle and adding tape color to its argument, and also setting tape color as a how do I say it? Setting local spares and giving that an attribute tape color, and then giving the default tire size. So here we say that because of LSP, all of the subclasses from the bicycle class should pass the same tests as their superclass, meaning that they should behave similarly to the bicycle class. So here's the bicycle interface test, and it just says, hey, do you respond to tire size, chain, default chain size, tire size, and spares? And that is a module. Just, I still like the whole using modules. It's very Ruby-esque. I really like it. So here we see that she creates a bicycle test and calls an instance of bicycle, and then another one called road bike test. And she still includes that module, bicycle interface test, and she instead has an instance of road bike instead of an instance of bicycle. And she runs both sets of tests, and they both pass the bicycle interface test, as you see here. Really cool. So now there is the subclass test. So here the subclass test is like, I'm just making sure that my subclasses still respond to post-initialized local spares and default tire size, that they haven't been so radically changed that they no longer, that these tests will break. This is kind of like a sanity check on making sure that those subclasses still kind of work, even though they might change differently. So we see that the road bike passes all of those, meaning that it's similar to what the designer wanted. We have now a mountain bike as well. Still the same idea, just including the modules and making sure that object is set, and then setting that to bike. Here is what I brought up before, where bicycle, when it has default tire size, I think it's to ensure that a bicycle instance wasn't created, and that an actual subclass was created. So the idea there being, there should be no objects, bicycles being used anywhere. Always some sort of subclass that inherits bicycles. So here we just have a simple test saying that yes, if there was a subclass, it would have redefined default tire size.
Proving that the superclass will fail if it's initialized.
Right. Because all the subclasses, like the road bike, the mountain bike, all redefine default tire size. So see, it still calls bicycle interface test, but I think that's the reason why it has this argument here in initializer, giving some tire size that allows it to create a superclass instance bicycle, and still have it pass the tests. So,
well, not quite. That's I'm not certain what the pass in is, but the test there specifically shows if you call default tire size on something that has not on an instance of a direct instance of bicycle, it will throw that error.
Right.
So when you inherit it, if you don't override it, you will also hit this issue. So somewhere else, I believe bicycle interface has already tested for that one. It tests that you can call it, and it's not supposed to have an exception.
So I think if I can rephrase that, is that we were able to create a bike instance because we gave it this tire size to use, so we can have an actual superclass instance that we can say, hey, if we call default tire size, we should raise a not implemented error. And I think that's the point of this code snippet, just to make sure the functionality that we don't actually create a superclass bicycle instance.
Right, you do right there on line 5.
Yeah, that's true. It's tricky. It's if when we do create a bicycle instance. I mean, if we do create a bicycle instance, and if we call default tire size, there should be an error that pops up.
Yes, that's what it's testing.
Finally, testing unique behavior. So we're going to look back at the road bike, and we're going to create an instance of it. We still have our test modules that we're calling. But now we're going to say something where we say, hey, we want to ensure that when we create an instance of the road bike with tape color red, that when we call local spares, that its tape color is red. And so it passes all the previous tests, as well as puts tape colors and local spares. Fairly simple, not much to expand there. I guess it's just to make sure that we can say, hey, I want to test this really specific thing about this subclass. So we're going to finish testing the superclass. So I guess we're going to create a new subclass for the bicycle called stubbed bike. And a few of its new definitions are that for local spares, the saddle is painful and the default size is 0. It's very funny. So we go and we create the bicycle test. We have an instance of bicycle, but we also have an instance of stubbed bike. So it's like a double entendre, one that we have a very stubby bicycle that has very small wheels and painful saddle. But also I think it's to highlight that this is now a stubbed object. So here we see that bike, because it's the superclass, raises an error when default tire size is called on it. But we see that local spares, spares. Local spares. Okay, so here's local spares. That's being painful. So it shows that when spares is called on stub bike, we now see that local spares includes, well, which was saddle, is now part of the spares method. Yeah. Test pass. And then we bring in the old, another test module, which just makes sure that it responds to what all subclasses for bicycle respond. And that's it. That's the end. We now have some understanding of, well, I have an understanding of, using modules to have different objects that have similar behaviors and be able to test them efficiently and easily without a lot of rewriting. I got an idea of superclasses and how they should behave and how we should test for that behavior, and then similarly using those modules to test subclasses and making sure they behave the way they should. I really enjoyed this chapter on tests. Definitely gave me a better overview of how to and when to test. I want to know like what other people think and if there were any new things that they saw or if there were any questions. Maybe have a little bit of discussion.
Yes. Anyone else besides me and sometimes Diego have an opinion? Alex, Don, Sam, Red. Oh, Bill's unmuting. He's going to say something.
Hey, can you hear me?
Yeah.
Yeah, I just wanted to comment on the topic of anticipating the interface to change. Any dynamically typed language, I write a lot of JavaScript personally, but I just felt so dirty by like writing a bunch of, hey, I got to anticipate this interface changing, and like some of those interfaces never change, some of them do. So I kind of like what you said about just using the actual objects. I found that to work, I think, both in Ruby and in other dynamically typed languages as well. I was just curious if anybody else had a strong opinion either way.
Well, you know where I stand.
Yeah.
So it's something that comes full circle. I think, part of mocks, especially in dynamic languages, give you so much power. You go, oh, I can step out everything and have no dependencies, and it'll be lightning fast. And in the case like RSpec, the syntax allows you to write it with the intentions right there on the line. And so you can make things really clear. The problem is you learn after you stub your toe a couple times, oh, you can hurt yourself. She showed a good example of hurting yourself. And it comes back to, well, if you can use the real object, you save so much stuff. Like the whole parts of this go, well, you don't have to do it all if you just use real. And then someone will argue, well, why do you have another class? Well, when that happens, write another test. But at the moment, I don't see it happening, so why bother? And then even like, so if we're going to talk about Rails, it's like as much as possible, I try to use the active record object.
Mm-hmm.
Now, I won't save it. I'll do something .new. If I only need methods, and I'll set the parameters, so hopefully the math works out. Then I exercise. Then it acts the way it does because it is the thing. Now, technically, that breaks the unit test rule where, oh, well, I can't use this other object. It's true. It's technically not a unit test, but I'm isolated for the fact that the one that I'm actually using will work the way it's working.
Yeah. And that's kind of what I feel too. Like, my tests serve another purpose, right? Like it's describing how the application works and how you would consume these objects, etc. So I feel like if I have like a new object in the test that is a collaborator, my tester, instead of doubling that or, using mocks, I'm saying it's intentional for these things to collaborate.
Yeah, that's true too. I mean, I think, again, in some cases where you're supposed to deal with multi-classes, like the preparer, that's good. But also that's good, again, that uses that classical, just everything has a prepare trip method. So that makes it easy for you to add, but you go and you test it, and then you can. Well, the question is, just a real quick side thing. When I look at this chapter, I learned two things. RSpec does a lot for you as far as making things convenient, easy. Like Andrew is amazed by modules, which is a default Ruby way to share methods without cutting and pasting. Whereas RSpec goes a little farther and has shared examples. And then you can have the intention, acts like, blah, blah. It's just the wording. Or like, if you look at like tests here, you say, you always have to define a method test, because that's how the meta programming figures out what is test. You always have to test underscore. RSpec lets you have context and specify or describe and it lets you write words and organize things in ways that make you better. So a lot of these, they go organization's better, texting is better. And I lost train of thought of why I diverge onto RSpec. Can someone tell me what we were saying just 2 sentences ago?
No, I think you were saying what you observed through the chapter itself. Like, here's other things, you know, that I saw. And so I agree. We kind of finished up the discussion on, hey, using an actual object instead of a double. So kind of just follow on, like, hey, also look at how much RSpec is actually doing, because you have to kind of roll your own when you're using Minitest.
Yeah, it goes to hell. If, you know, assuming most of us are Rubyists and we use Macs, it's like, well, technically it's the same as a PC, except it's different. It's a little better experience-wise. I would say RSpec gives you the ability to put your intentions and group things and just make things a little clearer. But of course, you could always write baloney and all those things. You could write, you know, describe this, context, it should test, you know, context test this. You could write just as bad and have no organization too. It just makes it a little easier if you're going to do that. And like the mocking ability is super convenient. And like when Andrew was having a hard time parsing how the Minitest mock, he didn't know what it did. Oh, well, the RSpec mocking is super clear. You know, expect object to receive this method and return blah, blah, or to receive with. It's like there's no ambiguity in that format. And then when you don't care to return it, you don't put it there. It's most likely the second parameter on that mock is what it returns. Some return true, some return nil. But you have to guess. Anywhere you have to guess parameters, a figure is bad frame. And if you don't care, you don't set it. So in a RSpec mock, expect blah to receive blah, blah, blah. If I don't put a return, then it's not, I apparently don't care. So intention is good. All right, so we kind of wrapped up on here. We should pick what book we'll do next. I would kind of recommend maybe design patterns. She brings up a 2, observer, some other things. Knowing design patterns is useful. If we were to do design patterns in general, design patterns explained is really good because it's meant to be read all the way through, whereas the Gang of 4 design patterns book is a reference material. So it's like grabbing a dictionary and just reading it. That's not the best way to absorb it. I can't remember. There's a design patterns and movie book if there's not by whatever, the red colored company that does the video with red color. I forgot. We could do that one. We could do something more testy, TDD or mock, or maybe we should build up. In my mind, we did a little OO. I think design patterns is probably good. Middle step, and then maybe we'll do some testing, simpler testing to more advanced testing. There's some really detailed testing stuff. Oh, and refactoring. Refactoring might be good, but refactoring could go after design patterns because there are patterns in refactoring. So I would suggest something design pattern-esque. I don't know what other people think.
We should do Elixir stuff.
Ooh.
It's possible.
Elixir.
So tell you what, maybe I'll make some kind of poll. You tell me what you want, but suggest to me some stuff. I'll throw an Elixir thing. You have a particular book?
I read a. Oh wait, am I muted? No, I'm not muted. There is this book. Let me see who the author is real quick. Yeah, I read this book called. Well, I read the first half of it. Called Elixir in Action by Sasha Zurich. And it's really good. I mean, it's I pretty much only do Ruby for my job, but it was just fascinating to delve into functional programming, which I know almost nothing about. And Elixir and then the Beam virtual environment is like pretty fascinating. So it's a cool new way to look at different problems. And yeah, it's pretty neat. I don't know how practical it is unless you're WhatsApp, but
it makes for an interesting. Yeah, no, it's I'll put a vote up. Anyone else want to suggest anything? I'll throw that book. I'll throw some design patterning stuff, maybe refactoring, and we can vote. Actually, guys that are not in our company, got to send me a message somehow. I know Bill came across this for OC Ruby. You can send me a message to that one. I guess Sam can send something to Don, and the rest of you guys know my email. So send me some suggestions. I'll throw a poll up. And Yeah. All right. Anyone have any suggestions besides me and Sam?
Think about it.
All right. Well, thank you. This wraps up POODR. And 2 weeks, we'll start something new. You also have to pick someone to do. So if it's design patterns, I'll do one. I'll start it. Okay. All right. I'll be in touch. See you in 2 weeks.
Thanks.
Thank you. Bye.
Thanks, guys. Good job on the talk. That was good.
Thanks.